So we are skipping over lesson 4.8 and we're going into lesson 4.9. Lesson 4.9 deals with both parallel lines and perpendicular lines. We're going to start with parallel lines. That's why we did the exploration on those. So I want you to, right now, I want you to put a box around, circle around something. I want you to point out what the definition of parallel lines really is. Two lines are parallel if they lie in the same plane, so coordinate plane, and have no points in common. In other words, they will never intersect. They will never touch each other. Well, we just discovered, and they're telling us right here, this is what you can count on. If, would you put a big star or something right by that? If the lines have the same slope. We just discovered that in that exploration. If they have the same slope. But then we also have to talk about, add just one little thing to it, but different y-intercepts. They have to have different y-intercepts. Because if they have the same slope and the same y-intercept, what would be true? What would be true if we had two lines that have the same slope, engage here. This is not going to be easy stuff if you don't. What would be true if they have the same slope and the same y-intercept? So imagine, like just make up an equation. Y equals 3x plus 4. What's its slope? Y equals 3x plus 4. 3. What's its y-intercept? 4. Okay, imagine another one that has that same exact slope and that same exact y-intercept. What would be true? Would they be parallel to each other? So another one that has a slope of 3 and a y-intercept of 4. What would its equation be? So you don't need to write this in your notes. I just need you to be able to see it, apparently. I said I have that line. You just told me it has a slope of 3 and it has a y-intercept of 4. And I said, okay, well, what if we have another line that has a slope of 3 and a y-intercept of 4? What would its equation be? Same thing. So if it's the same thing, it's the same what? Don't write this in your notes. It might confuse you. It's the same what? Same line. It's really a line with another one wrapped right on top of it. It's really the same line. They can't be parallel when they touch, right? So we have to keep in mind that when we have lines that have the same slope, that's important, but they also have to have different y-intercepts. Otherwise, they will be the same line. Okay, and then we're going to go over here and talk about what kind of lines will be parallel to horizontal lines. So a horizontal line, tell me something about what a horizontal line looks like. Give me a visual. What's a horizontal line? Yep, like this. Okay, what kind of a line would be parallel to that? Here, another horizontal line, right? So horizontal lines will be parallel to other horizontal lines. By the way, let's just kind of revisit. What kind of equation do we have for a horizontal line? What's missing in the equation when you have a horizontal line? Either the x's or the y's are. The x's that are missing. Because remember, horizontal line has 0 slope, so 0 times x wipes the x out. So y equals a number. You know what? Maybe we should just write that right here so we remember that. When you have y equals a number, there's no x's in there. It's just a number. You have a horizontal line. Well, what's a vertical line? Give me a visual of a vertical line. Okay, what would be parallel to a vertical line? Another vertical line. Yeah, another vertical line. So vertical lines will be parallel to other vertical lines. And anybody know what's missing in the equation of a vertical line?
The base.
No, then it's a horizontal line. But this time it's going to be the y's that are missing. So the equations for vertical lines are x equals a number, no y's. X equals some number. Then you have yourself a vertical line. Okay? So here's an example, just kind of for us to take a quick glance going to show us how we're going to show work for our first part of our homework. Identify which lines are parallel. So we have equation number 1 here, we have equation number 2 here, and we have equation number 3 here. And we're supposed to identify from the equation which of those are parallel. So here's what, I want you to put an arrow like this. Here's what we need to show. We need to show the slope and the y-intercept for each of the equations that we are going to use to help say, well, these guys would be parallel. After we do that, then we're going to say, oh, well, since the first equation and the third equation both have a slope of -2, and both have different y-intercepts, they're not the same y-intercept, we can say that those guys are parallel. This supports our answers. Okay, that would support our saying those guys would be parallel. And then we would graph them, and the graph should prove that they're parallel. Okay? So let's go practice some. Number 1, identify which 2 lines are parallel and then graph the lines. I think it might be kind of helpful if we give them some numbers, so let's do this. 1, y equals 4x plus 2. Let's identify, if it's in a slope-intercept form, which it is, we can go right to identifying its slope and its y-intercept. What's this one's slope? 4. What's this one's y-intercept? 2. Okay. The second one, let's call it the next equation, number 2. Y equals 2x plus 1. What do we have to identify? M and B. What's this one's M? 2. What's this one's B? 1. Are those 2 lines parallel? What do you think? Those 2 be parallel? No, why not? Don't have the same slope. Okay. Number 3, our last equation, y equals 2x minus 3. What's its M? 2, and its B? -3. Okay, is that one parallel to one of those other ones? Which one? To number 2. Okay, so let's circle these 2. And we're going to say that y equals 2x plus 1 and y equals 2x minus 3 are parallel. And then we're going to graph it to prove it. Okay, so let's graph the first one. And it has number 2. The one that has a slope of 2 and a b of 1. Where will we start on the graph? Where will you put your first point? At 1. So we'll put our first point at 1 for the first equation that we're going to graph. And it has a slope of 2. What are the 2 ways we can do that slope? Up 2 and right 1. Or what's our other option? Down 2, left 1. Okay, and it has a positive slope, so it's a good thing if our line is rising from left to right, correct? Draw that line before we even move on to the other one. Now, if you still need to write down all those little helpers to help you graph, by all means do that. I'm hoping that at some point you can do it without, but if you're really not getting them right, don't quit too early. Okay, let's do the other one, number 3. Its starting point is where? -3. Has the same slope, up 2, right 1. Down 2, left 1. Draw the line. And it appears we picked a good pair of equations. want you to go start number 2 when you're done graphing number 1. I want you to start it. You have a model up above to help you, show what kind of work you should show. And those of you who have been kind of stubborn about this, you know, like, I don't need to do what you're telling me to do. I think it's time to give in. Last quiz proved it. Do we have any parallel lines? Yeah. We do. Okay, which ones? 1 and 3. Everybody agree? Because why? What's the reason again? Same slope. What else though do we have to check out?
They got different B values.
They have to have different B values, right? And they do, don't they? Okay, so number 1 and number 3. So we're gonna, first of all, before we graph them, we're gonna say here's what we believe. We believe that y equals negative 2/3 x plus 1 and y equals negative 2/3 x minus 2 are parallel. And then we'll go graph it to support our answer. What's the problem with number 2? Why can't number 2 be part of that party? It's got a negative slope.
It doesn't have the same slope, and it also has the same B value.
Has it? Okay, so it's got the same B value as one of the other guys, but it doesn't have the same slope. Negative 3/2 is not the same as negative 2/3, is it? In fact, what relationship do they have? What are those called? Negative 2/3 relationship to negative 3/2 is what? It's an R reciprocal, yeah. They are reciprocals. So we don't want reciprocals for this. So we're going to go ahead and get this graphed. What is a negative 2/3 slope? Act
Go
like.
down 2 to the right 3,
Okay?
and then you would change it to positive 2 and negative 3, so you go up to left 3.
Okay, good, Adam. Again, we should be saying to ourselves they both have a negative slope, so they both should be falling from left to right. And we decided they were parallel, so do they look like they will ever touch? No. So they are parallel lines. So this is determining when lines are parallel to each other from the equations. So it isn't from the graphs, it's from the equations. We start by identifying from the equations. We're using the graph to help verify it. Okay? Anybody have any questions on this part? This is the first of your learning goals. I can identify and graph parallel lines. Okay, let's go to the back side then. This is going to be the challenging part, probably. The other learning goal we have today says I can find the equation of a line. So in other words, we get to write the equation that's parallel to another line through a given point. And here's what they're going to give us. So let's look at this one right here. Write an equation in slope-intercept form. That's the equation we have to write for a line that passes through ordered pair 2, 4. So it's kind of like this. They're saying you got this point on the graph, you need to get the equation of the line that's going to pass through that and is parallel to y equals 3x plus 2. So since that one has a positive slope, I know it's going to rise from left to right. So basically, here's what I need. I need to find the equation of the line that's going to go through that point that's sitting out there by itself. That's going to be parallel to the given line. So first thing we're going to need to do, and you need to follow these steps, okay? Step 1, we need to find the slope of the given line. Because why is that important? Because the other line is going to have the same slope. It's going to share that slope. Well, that's going to tell us what the m value of our new line should be. Because in step 2, now we're getting ready to write our new line's equation. So we take the slope that we found up in the other one because that's its slope, so it has to be this one's slope. It has to go through this point, so we call these x sub 1, y sub 1. And we do our, what's this called again? What's that equation called? Point slope form. We're going to use point slope form, substitute into it. Step 3, we're going to get it transformed into slope intercept form. Okay, so I actually didn't do a very good job here of where this line should be. I can already tell it should, instead of being below that point, it should be above it. Okay, so let's graph these just to verify that the person who did this work got it right. Let's graph the first line. So our y equals 3x plus 2. The slope is 3, so this is our first line. Its slope is 3. What's its y-intercept? 2. Okay, let's go graph that one. So we're going to start at 2. What does the slope of 3 tell us to do? Up 3 to the right one. Or what's our other option? Down 3 left 1. Okay, draw that one slide. This is what we call the given line, the one that they gave us the equation for. Here's our given one. Let's put by it y equals 3x plus 2. This is the one they gave us. Now, they say the second line, let's go over here and put here, second line, the new line. What's its slope again? What's the slope of the new line? It'd be 3, just like the other one. What's its y-intercept? Negative 2. So we're going to go to negative 2 and start. And use the same slope as we did for this last one. Up 3 over 1. Oops, I went 4. And draw our line. At the tip of that one's line, put its name, y equals 3x minus 2. So they should not meet. Now, if your lines don't look like, because mine look like eventually they might at the top meet, you know what ends up happening, and I'm going to start suggesting that we maybe do this, make more than 3 points. You know, just kind of like cover the graph. So I could have gone up another 3 and over 1 and see how my line would have got a better picture of it. And this one I could have gone down 3 and over 1. I would have a much better picture of the, see how the more points we make, the better our lines become. Okay, let's go practice our own now. Write an equation in slope-intercept form. The line that passes through would appear -1, -3, and is parallel to y equals -x plus 4. So you know what, first thing we need to do is we need to identify what are some of the important things that are given here, okay? So in step 1, remember we were supposed to do these in steps. This is our given line. So our y equals negative x plus 4. What's the important thing that we need from this line for our new line that's supposed to be parallel? Not yet, that's going to come in the next step. What do we need from this one? The slope. Remember, because the other line has to have the same slope. So the slope is negative 1. Okay, the slope is negative 1. So now we're going to go to step 2, because now we're starting to work with our new line. Okay, and I want you to put here new line. The new line. What's its slope going to have to be? Negative 1. That's what we needed from step 1. Its slope has to be negative 1. What point does this line have to go through? Negative 1, negative 3. Negative 1, negative 3. So x sub 1, y sub 1. How does point slope form look without any substitution going in at first?
minus y1 equals m, and then whatever, yeah, that, and then x minus x1.
X sub 1. Okay, write that down. Because now we'll substitute into it. Okay, so y minus what? Negative 3. M, what's going in for that? Negative 1. X minus negative 1. Let's clean that up. What can this side become? Y plus 3 equals, we're not doing distributive property, we're just cleaning up right now. So negative 1 will just leave us negative 1, and what can we do with that? X plus 1. Okay. Now we'll go up to step 3. Because in step 3, we're going to put it in slope-intercept form. So we're still working on the new line, and you can arrow over here and say we're still working on the new line here too. Both places we are. Both places we're working on with the new line. Okay, go ahead and get that put in slope-intercept form. That's what we were just doing in our last lesson 4.7. You know how. What's the cleaned up, how we would see the answer equation name for our new line? What do you have?
Negative x minus 6.
Okay, negative x. But I'm going to disagree with minus 6. Can you tell me how you got minus 6, Macy? Okay. Everybody, do you guys agree with me and Andrea on it should be y equals negative x minus 4? Okay. So this is our equation that they asked us to get, so circle that. That's our final answer for the equation of the new line. And now we're going to graph. Okay? So maybe a good thing to do with this one is over here, let's write down the things that'll help us graph them. So y equals negative x minus 4. This one we need a negative 1 slope and a b value of 4. This one we need a slope of negative 1 and a b value of negative 4. Let's go get those guys graphed. See if they are parallel. Make lots of points. Make more than 3. Make them till you're sick of making them. And remember what we're going to do. We're going to mark on the graph so we remember which one we graphed, which one it represents. Oops, I already know mine's wrong. Slope is supposed to be -1 and I didn't write my negative sign here. Should be falling, shouldn't it? Hope you don't copying me, because I'm wrong. I wonder if I can undo a line without having to go there. I don't know.
Can you just do the back one?
You can, but sometimes it takes forever. That was what I was trying to avoid. Yeah, I'm thinking that I'm too short.
Yeah, and it won't just let you erase it right.
I know, it's like just crazy. But well, you have to undo the line. There we go.
Seems like there should be an easy.
Yeah, I gotta figure that out. Definitely. Or not make mistakes. Okay, I think mine's right now. Do you agree with me? So it appears they are parallel, doesn't it? Okay, we got one more to do here quick. So ready to dive into the next one? Okay, step 1. This is our given line. It's y equals 2x. What's the important thing we want from this step? We don't really need to worry about b in this step. We need the slope. Yeah. What is the slope? 2. Because then in step 2, we say, oh, well, I need a line parallel to this line. This is my new line. It has to have a slope of 2, or it won't be parallel to it. And it has to go through ordered pair 2, -1. So I have my x sub 1, y sub 1. Y minus y sub 1 equals m times x minus x sub 1. We'll substitute in.
Do we really need to do that on paper, since we already know what that is?
I will let you skip that, I guess. I can be kind and let you do that. If you don't get these wrong. If you get them wrong, then I'm probably going to have to change my mind. So we get the new lines and point slope form name first. Then we go up to step 3 and we put that into slope intercept form. And I'm going to change my subtraction to add the opposite. So remember, the new line is used in both of these. Okay. Don't forget to circle your final answer cleaned up. And then see if you agree with me or if you need to change my mind. Anybody agree with me yet? Yeah, got a couple new people, good, okay. Then we're gonna go and graph them. So y equals, we got the y equals 2x to graph, and we have the y equals 2x minus 5 to graph. So m equals what for y equals 2x? 2, yeah. What's its b value? 0, yeah, 0. When there's nothing being added or subtracted from the x's, that means your b is 0. Your starting point is 0. In the other one, we have the same slope of 2, but a b value of what? Negative 5. Okay, go ahead and graph those, see if we came up with a good graph. Now, there's one thing we forgot to do in the last one, we'll go back and do it for both of these in just a moment. Let's let you get these graphed first. Okay. After you have them graphed, I need to mention something to you about why, another reason why we graph them on these problems on the back side. We do want to verify that they're parallel, but just as importantly, we want to make sure really that new line really goes through the point it was supposed to go through. Okay? So let's go back to number 3. The new line, remember the new line is our x minus 4 one, so it's this one. It's supposed to go through ordered pair -1, -3. Is it? There, it's going through -1, -3. So we came up with a good equation. Do this on your notes, please, because I want you to do it in your homework too, to make sure that you get there are lots of lines parallel to the given line. Lots of lines parallel to the given line. But only one line parallel to the given line going through the point they gave us. So now we're going to go to number 4 and verify that our new line, which is the one y equals 2x minus 5, is it going through ordered pair to -1? And here's 2 -1 right here. So again, we did well because our line for our equation that we got is passing through the point that they wanted it to. So any questions on, these are the ones on the back that they require a fair amount of work and some thought process going as you're doing them. Any questions? Okay, I'm going to get your homework out to you, and you can do your homework right on the worksheet itself. There is space to it. Or you can choose to use line and paper because that works better for you. So on the front side, you are doing the same thing we were doing on the front side of notes. On the back side, you're doing the same thing as we were doing on the back side of the notes. So it kind of like follows along. Use the front side of your notes on the front side of the homework. Back side of the notes on the back side of the homework.